Okay. What you are seeing is a lesson where I am showing my students how to solve algebraic equations using fractions. Okay, we're just turning around and watching. Okay, so somebody has to help me remember this fraction, okay? 6p, that's the equation I should say. 6p is equal to 4/9. Alright, just in case I forget. So, this is our practice set. If you haven't labeled your blank sheet of paper practice set, that's what you want to do, practice set. And you want to give it a further title that says solving equations. Solving equations with fractions. Double use with a slash means with. You want to date this for 2/8, and we're going to say it's topic 2, lesson 2.5. That way, when you go back to study your notes, you can actually know what kinds of information you'll find here on this sheet of paper. Now, everybody's pencil or pen should be in motion because we all should be writing down the same thing, okay? And remember, you have to make a choice, guys, on a daily basis to be in tune and focus on what's going on in the instruction, I should say, that's going forth in this room. Some of us are looking very lethargic and tired. We want to sit up and perk up, okay? Caleb, I need you. So our first practice problem says 6p is equal to 4/9. I said Caleb, ladies and gentlemen, don't worry. 6p is equal to 4/9. Okay. So if we consider the algorithm for solving any kind of equation, the first thing we have to do is identify the number that we need to remove to isolate or get p all by itself. In this case, which number do we have to eliminate to get p by itself?
6.
Thank you, Zachary. We have to eliminate the p. Okay, we're going to keep going, but please remember to pay attention to who I call on to provide me with the information I'm looking for. All right, so I need to eliminate the 6, right? In order to get rid of the 6, I have to do an inverse operation. Well, let me take a step back. What operation is involved in this problem, Evelyn? 6p equals 4/9. What operation, what math operation is being used currently in the problem? Huh? Division. How can you tell that? Because you see a division sign. Well, that division sign is actually being used as a fraction. What's the operation in the problem, Caleb? Multiplication. And I know this because what? I see what? What do you see that lets you know that this is a problem? Yes, anytime you see a 6, you see a number next to a variable that needs to multiply, right? All right, moving on. So we know 6 is what we have to eliminate. We know that we're going to use division because it's the inverse of multiplication. So what we're going to do is we're going to divide the left and the right side of this equation by the number 6 that we're trying to get rid of, right? And so the way you can do this is simply write divided by 6 on both sides, okay? So please do that with me. And I think we've all done this. As long as you keep up and take the notes, I think this will make sense and begin to sink in. On the left side, these two inverse operations cancel the 6 out, right? And so I'm left with only a p on the left side of the equation. On the right side, I now have 4/9 divided by 6, right? That's what I'm left over with. However, I'm trying to take a fraction, and actually I'm trying to take a whole number. Hold the question for just a second. I'm attempting to take a whole number and divide it by a fraction, which I cannot do. You can never do any kind of computation of a whole number or fraction until you get them written in the exact same format first, right? like if we're speaking two different languages, we're not communicating right now, right? So we have to find a common language to speak in. Please put that hat away. When I'm completely done, Zachary, you can ask me a question that helps clarify, something that's confusing, unless you want to know how I got something that's currently up here. Is the question to ask me how did I get anything that's up here? Okay, well, hold tight with that question, and then I'll go back. So as I said, I can't take a whole number away from the fraction because they're not written in the same format. Does anybody know what I need to do to get the 6 ready to be divided by the 4 ninths? Zachary? Well, just to set it up as a fraction, I do have to give 6 the denominator of 1, right? Which is basic. 6 over 1 is still 6. I'm just writing it in fraction format so that I could go ahead and divide, right? Okay, and so now that it's set up like a fraction, I can go ahead and divide. But as we said yesterday, and I'm going to extend this board, as we said yesterday, when you divide fractions, you're actually multiplying by the reciprocal of the second number. And the reciprocal of 6 over 1, and I'll just write reciprocal, you do the same thing, is taking 6 over 1 and flipping it upside down. And so when I multiply, I'm going to be multiplying by 1/6. So that's what you'll see me write next. P is equal to 4 ninths times 1 over 6. Now, nobody should be typing or manipulating anything on their Chromebook. We're not on the Chromebook. We are taking down a very specific set of notes, which you see on the board. Okay. Now, I'm going to say this to help you out. I don't want to confuse you. When I look at P is equal to 4 ninths times 1/6, I can see that there are ways to simplify. Let me say this to you too. Simplification or simplifying is all about making numbers smaller. Why would we need to make numbers smaller? Why would I take the time to make any of those numbers in that fraction smaller? Caleb and Zach. So it would be easier to solve it, yes, but easier to multiply, right? Let me show you this. If you look, and when you simplify, you always want to look diagonally when we're at this point, right? If I look diagonally at 4 and 6, I can see that 4 and 6 have a factor in common. Remember, factors are two numbers that multiply together to produce this top number. 4 has 2 and 2, and 6 has a 2 and a 3. Can you see any number that they have in common? Lakaya, what factor do they have in common? 2, absolutely. So if I simplify 4 and 6, or divide them both by 2, I make those numbers smaller and easier for me to multiply ultimately. So when I cross out the 4, I'm simplifying, I'm dividing. And I'm saying to myself, 4 divided by 2, which is a common factor, leaves me with 2, right? And then 6 divided by 2 leaves me with 3. So now, when I multiply my numerators and multiply my denominators, it looks like this. 2 times 1 over 9 times 3. And just to compare, originally I would have been multiplying 4 times 1 and 9 times 6, which are bigger numbers to multiply. I want to simplify to make my numbers smaller and easier to multiply, okay? So now, I can figure out that P is going to be equal to the product of multiplying the numerator straight across, 2 times 1, which is 2, and the denominator straight across, 9 times 3, happens to be 27. So now I know that P is equal to 2 27s, right? Right, okay. That was a long way around the block, but at least now we've established how to solve this kind of problem, and I can give you a practice problem just the same. So just to review or recap, I'll take questions. Zachary? any questions about how I got anything on this problem?
Well, you cross up the two, and then, so you don't have to do any more to this problem, it's just like, you can't simplify it.
No, I can't simplify 2/27 any further because there is no one number that 2 and 27 have in common.
And then if you didn't cross up the two, would it be 4?
Yes, if I had not simplified, I would have ended up with this as a fraction. I would have ended up with 4/54, right? But then I would have been able to see, okay, 4 and 54 have a number in common. They have a 4 in common, right? So here's the thing. You either simplify here or you simplify at the end. Oftentimes it's easier to simplify here because then you don't have to simplify at the end of the problem. But if the problem specifically says simplify your answer, you're going to have to simplify at some point anyway.
Does 454 have something in
Yes. If numbers are even, if two numbers are even, they always have a 2 in common, right? If two numbers are even, they'll always have a 2 in common. Try dividing, Caleb. Try dividing 54 by 4. The rest of us, do we have questions? Okay, so we're gonna move on to. Well, you need to put your hand in the air, and then no, I'm not going to stop because I think we've had ample time. The only way you don't have time is if you weren't following right along. Okay, so I'm going on to the next problem. I'll make time later on in the period for you to go back and copy. I'm going to go back to the internet, come back to my practice buddy. You have to make sure you raise your hand, okay? Right, now do it by 2. What I'm trying to do is just find a multiplication problem to model for you. God bless you. And this is the same kind of problem. We'll go back and do that. Hopefully. Okay.
It's 27.
Okay. So you see they do have a number in common, right? 2 is the number they have in common. That's how you simplify. Okay, I'm going to model this one first, and I'm just going to stop and start a new session so I don't run out of time.